All right, so this is our third lesson on these triangles, and we're going to do a thing called congruence postulates. We already talked about how triangles are congruent. If all the corresponding sides are equal and if all the corresponding angles are equal to each other, then those triangles would be congruent to each other, all right? But we don't have, and so that's 6 things, right, that you got to show. We just went over that homework, didn't we? We had 3 sides and 3 angles that are equal to each other. That's 6 things that you would have to show in order for the triangles to be congruent. But you don't necessarily have to show all 6 things every single time, all right? And this is one of the times. We're not going to do them all today. We're just going to do a couple of them. But these are congruent postulates. So here's what the postulate, well, I'll tell you what. Let's put a picture on here. Let me grab, let's see, where to put my triangles. There we go. Let's grab this triangle. It's the same triangle we used earlier, but when we went over the homeworks, and then put it right there. Let's just make it a little bit bigger just so we can see it a little bit better. Make it about like that. All right. And then I'm going to copy and paste. And I'm not going to like flip them or anything like that. I'm just going to make them look exactly the same. All right. So we have a postulate. Now, Ben, you had asked the question earlier before we started recording. What is a postulate? Is it one of those things that needed to be proven, or what? Does anybody have an answer for that? What is a postulate?
It's one of those things that is always true.
That's right. It's just accepted as true. Right. It's just accepted as true. Now, theorems are true also. All right. They're not going to give you something that's not true. But this is true, but it can't be proven. All right. It's just true. You just accept it as fact. Everybody got that? So that's what a postulate is, all right? We will do some theorems. We will do some congruence theorems a little bit later, okay? I don't know, in a day or two. We will do some theorems that you could prove to be true, all right? But these are just accepted as true. So I'm not going to even use the letters and stuff in the book. We're just going to make this up ourselves, okay? Because it's not really that hard. So D, E, F. Now, what if I was given, all right, so they told us, or you could measure it, but they'll probably tell us that this angle is equal to this angle. Is that enough right now to say those triangles are congruent, just with that information? No, because, look, I could have this triangle a whole lot smaller, but still have that same angle, couldn't I? All right, so that's not enough. Just one angle is definitely not enough, okay? But they're going to also say that this side is equal to this side. That's still not enough to say that the triangles are congruent. But if I can show one more thing, okay, if I can show, let me make sure I'm doing the right one, I am. If I can show that this one is equal to this one. Now, how many corresponding parts have I shown equal to each other? I've only shown 3, right? I haven't shown all 6. So I don't know that angle B and angle E are equal. I don't know that C and F are equal. I don't know that BC and EF are equal. This is all I know right there. But this postulate says that that's enough to be able to tell that these triangles are now congruent to each other. Does that make sense? Before today, we would have had to shown all 3 angles and all 3 sides congruent to each other, or equal to each other, in order to say the triangles were congruent. But this, if this is all I can show, this is all they tell me that's equal from this triangle to this triangle, that's enough. Okay? This triangle will be exactly the same as this triangle if I've shown that amount of information. We have a name for it, and okay, it's a nice little, concise little name, but it's taken from this. If I can show that one side of one triangle equals another side of another triangle, and if I can show a second side is equal to a second side, and if I can show the included angle, now that's a word we haven't really used before. If I say the included angle, what does that mean? The angle in between. Very good. Okay, it's the angle in between those 2 sides that are equal. You follow me? It doesn't mean that AB and AC are equal. Everybody understand that, right? It means that AB and DE are equal, and it means that AC and DF are equal, and the included angle, the angle that's in between those 2 sides, if they are all equal to each other, then these triangles are congruent. So we give this a name. It's got a side, it's got an angle, and it's got another side. So we call this the side angle side postulate. See, I told you it's a nice little compact name, okay? We just call it side angle side. Okay, we do not, now we write it just SAS, all right? There's no reason to write out the words side angle side, okay? But we just write it SAS, but we say, when we say it verbally out loud, we say side angle side. Everybody got that? Okay, so this is how we write it, and that's the name of the postulate right there. All right? All right. What's that? Okay, good. All right. So let's do another one. They give you a whole reason why it's equal. They do a thing called constructions. In one of the chapters, we skip constructions. I used to do it in my other book years ago, but there's just not enough time in the year to finish the whole entire book. So there's some things that I think that are okay to skip, and that's one of the things that I decided that we could skip. You're really not going to do that in college or anything else. You're not going to have to do that on an SAT. So the stuff that we skip, I kind of know what you're going to need to know later on. You're not going to have to know it for Algebra 2 or anything like that. So I didn't do any of that construction stuff. But if you look in the book, they show you, not a proof, but they show you why this is true, all right? And they use constructions to do that, but we're not going to do that in here. So if you look in the book and you're like, what's all that stuff that they're doing in there? Mr. Hammer didn't talk about that. Well, that's true, I didn't. But that's okay. I think we're okay with that. Let's do this triangle right here for the next one.
You usually define that one angle and two sides and that.
Well, you don't necessarily have to find them. Sometimes they tell it to you, okay? And we'll take a look at some of the problems so you know, like, what are they going to ask you on the homework? That's what everybody's concerned about, I'm sure, correct? Give me some letters. Somebody give me your initial. What's your initials?
JT. PMR.
ADC. All right. Who else?
SJT.
What is it? SJT. SJT. All right. So we've got these two triangles. Now, we know if we have two sides in the included angle on one triangle equal to two sides in the included angle on another triangle, then those triangles are congruent to each other, right? That's what we just learned. Well, there's one more postulate, and it would be this. So now they're going to give you an angle equals an angle. They're going to give you another angle. Okay, so this one's got two angles. The other one only had one angle, right, equal to another angle. So this has two angles equal to each other. And now the other one had two sides and an included angle. This one has two angles and an included what? Side. Okay, so right there. All right, very good. And now how do we say it? What do we say verbally? We would call it angle, side, angle. And this is the angle, side, angle postulate. Again, you can't prove it. It's just accepted as fact. All right, this is a postulate. That's what it means. And it's angle, side, angle. Again, that side, notice, the side is in between the two angles when I say angle, side, angle, isn't it? And it's in the picture, it's between the two angles as well. All right, so that's how we write it. Now, you can't just have two angles in any old side, okay? You can only have two angles and the included side for this postulate to be true. All right, that's enough to show that these triangles are congruent. So now I could say, with that information, let's call this triangle, what do we call this? ADC. Okay, and we could say now that this triangle is congruent to this triangle. What would I call this triangle? SJT. SJT. They are congruent. And what's the reason? Why are they congruent? With all that information, what's the reason? Because of angle. Oops. Oh, I put a bad word. Okay. Angle, side, angle postulate. All right. So it's not the first time I've done that. All right. So it's called the angle, side, angle postulate. That's why these two triangles are congruent to each other. Okay. If they ask you why they are congruent. Now, again, here's another thing that we're kind of skipping a little bit, and I'm kind of having my doubts whether I should do it or not. But again, just for the sake of time, I'm doing it. So we're not doing proofs. I've said that 100 times already in here. We're not technically doing proofs, but this would be like the final reason why these triangles are congruent to each other, angle, side, angle postulate. But we're not really doing proofs in here. All right, so let's take a look. They don't really they don't really give you an example for what we're doing. I'll tell you what, let's do this. By the way, what I accidentally wrote down, there is no angle side-side postulate, okay? It's not just because it makes that word, okay? It's because it doesn't work. It doesn't exist, all right? That you can have an angle and two other sides equal on one triangle to another, and the triangles still not be congruent to each other, all right? So it's not just because of the word it makes, it's because it just doesn't work, all right? So let's see, what was the homework? 4.3. I'm just going to write the homework down, and then if we have got a couple minutes left. So this is what? Section 4.3, and it's pages 165, 166. You should already have this in your lesson plan thing. And then 20 to 23. So I skipped a little chunk in between. All right. So that's your homework right there. All right. So let's take a look at the very first one. I don't know if I even have time to draw this picture, though. Here, you got that? Right there. I don't know. Let me try to draw this. We've got this. I'm just going to try to draw it super quick. It's not going to be perfect, but you'll get the idea. You're looking at this, you're like, well, wait a minute, Mr. Hamrick, this is not even a triangle. Well, it kind of is, though. I see some triangles in there, don't you?
No, I definitely do.
Okay. And yeah, it seems like I'm going to run out of time here. What is that? D, B, and C. So let's see what they ask. Look at the first one. It says, name the included angle between AD and DC. AD and DC. This one right here. So what would the included angle be between those two sides? You can't just say D, though. You can't just say angle D, because there's three angles that come out of D. There's this little skinny one, there's this little skinny one, there's this whole thing. Which one is the included angle?
ADC.
Right, so the answer would be angle ADC. So that's kind of what they're going to be asking, all right? So make sure that you look at that. That's question 1, correct. So I've done 1 for you. All right, that's it.